In this video, I'm solving a problem involving 3 points in three-dimensional space, and the question asks if the points are collinear. This is part of a series that deals with applications of vectors. At this point, all we know about vectors is how to add them, multiply them as scalars. That means we could also multiply them by negative numbers so we could subtract them. We know how to find unit vectors in certain directions. We know the distance between points in 2D and 3D and NG, and we can find the midpoint and the equation of a sphere. So they're just asking us if these points are collinear. Now, I could get out my three-dimensional coordinate system and start graphing, but you know how hard it is to graph in 3D. And sometimes because we're graphing in 3D on a 2D piece of paper, those graphs aren't very insightful. Since they're not very insightful, it's helpful to just draw a cartoon of this. What do you mean a cartoon? Well, let's think about the possibilities. They're asking if the points are collinear. They're asking if these points, the way of saying that is, do these points lie on the same line? If they do lie on the same line, we want to know, and we're hoping vectors can help us figure that out. So let's imagine you've got 3 points. I'm going to call this point A, I call this point B, and this point C. And I want to know if all these guys are on the same line. Well, if they are on the same line, I don't know where they are relative to each other. They're not necessarily the same distance apart, but maybe A is over here and B is over here. And C, C could be in between them, C could be down there, C could be over here. But if they're on the same line, C is somewhere over here. Isn't it true that if A and B and C all lie on the same line, if I come up with a vector AB and then I come up with the vector AC, they would have to be constant multiples of each other? Doesn't that vector have to be parallel to that vector? And if those vectors are parallel, doesn't that mean that this vector is just a constant multiple of this one? Okay, so that's one possibility. If they all lie on the same line, they're going to be multiples of each other. Let's say they're not on the same line. So here's A, here's B, and then here's C. Well, then the vector from A to B and the vector from A to C, they're obviously not multiples of each other. Now, I've drawn it in 2D, but this could be in 3D. You just have to look at it from the right angle when you're in 3 dimensions. So from the right angle, our picture might look something like this. So we see from these pictures that if these 3 points lie in the same line, then the two vectors AB and let's just say AC, they have to be parallel to each other. And vice versa, if they're not parallel, and let's, before we go farther, they have to be parallel to each other. And what that means is that AB has to be some constant times AC. Or the other way around, you could put the constant on either side, that's fine. So, or let's say it even a different way. AB needs to be a multiple of AC if they are truly parallel. So let's just see. Let's see if they're truly parallel. We'll figure it out by calculating the vector AB in component form and the vector AC. And then if they're parallel to each other, or if they're multiples of each other, then we know that this is true, and then if this is true, we know that they're parallel to each other. And if they're not parallel, this doesn't hold. So this should really be, if this is true, then this is true, and if this is true, then that is true. It actually goes both ways. The implication goes both ways. So let's calculate AB. So you're going to use terminal minus initial. I'm going to start with the coordinates of B. So 7, -4, -1. And then I'm going to subtract the coordinates of A. So subtract 1 -2, and 5. 7 minus 1 is 6. 4 minus, or -4 minus a -2 is +2, and that's just a -6. And so the vector AB is just 6, -2, -6. All right, that's cool. Now we're just going to calculate AC, see what we get. Same thing, terminal minus initial. Where do you end up? You end up over here at 4, 2, -3. So we're going to start there. You want to subtract the coordinates of A, which are still 1 and -2 and 5, and simplify. 3 and then 2 minus a -2 is 4, and that's -8. Question is, if I multiply this by a constant, do I get this? Most people just say no, and say, how do you know? Because I know. I'm like, oh, how do you know? Well, first of all, this is how I think through it. I ask myself, I've got AC here and AB here. What do I have to multiply this 3 by in order to get the 6? You know, I have to multiply 3 by 2 to get 6. So the only possibility, if this AC is parallel to AB, 2 times AC would have to be AB. That's the only way it would work. So let's see what 2 times AC is. Oops, C, not B. Distribute your 2. Is it the same as the AB? No, the 6 is the same by design. That's good. But when I multiplied by 2, I got an 8 there and a -16 there. I didn't get a -2 or a -6. That's not AB. So that means AB is not parallel to AC. And look at our pictures. If AB and AC are not parallel, it's going to be something more like this in 3 dimensions. So A, B, and C are not collinear. All right. That's one of our applications.